Hello everyone, myself Dr. Ramesh Kumar Gajula, Assistant Professor, Department of Chemistry, Vardhaman College of Engineering. Today we are going to learn about rubbers. As we know that rubbers are also polymers, but they are not plastics. The small difference is there in between both rubbers and plastics. Rubbers can show the elasticity nature, but plastic they won't possess that elasticity nature. That means if we are doing the stretching, rubber materials they can come back to their original shape, but plastic material while doing the stretching they won't come back to in its original position. So that's why all plastic materials are polymers, but all polymers are not plastics. One best example, that is rubbers. Today we are going to discussing about that rubbers material. So here you can see rubbers are also known as elastomers. Why they are elastomers? Because they can possess elasticity nature in its backbone of the structure. What is the helical chain structure? So just here I am going to write that helical chain structure. So this type of structure is present in its backbone of the rubbers chain. So here I am going to showing with a small demo. So this is the helical chain structure. So with this helical chain structure, while stretching the rubber material, it's going to come back to its original position. So that's why rubbers are known as elastomers. So here once the small definition is there, that is the rubbers mean rubbers are high polymers. They can capable of returning to their original shape or size after being stretching. Now here you can see this is the rubber material. Now I am doing the stretching. Stretching mean being made a large. So here you can see the clearly while I am doing the stretching, rubber material is going to becoming a large, being made a large material. Now I am going to removing the stretching, it is come back to its original shape. So these materials are known as rubbers materials. Now these are the some of the characteristics of rubbers are there. They are high tear and tensile strength, good resilience, and they are good resistance to water nature. So these are the some of the characteristics of the rubber materials. And next one, based on the origin, rubber materials are classified into two types. They are natural rubbers and synthetic rubber. Now here the natural rubbers are made up of with natural resources, that means plants. Now the synthetic rubbers, these rubbers are prepared in the laboratory by using some chemical components. These are the some of the examples for synthetic rubbers. They are Buna-S rubber, butyl rubber, silicone rubbers, styrene rubber, and nitrile rubber. These are the some of the examples for synthetic rubber materials. And next one, moving to natural rubber. How we can synthesize the natural rubber? Around the globe, more than 200 variety of rubber plants are there, but among them, one of the most promising rubber tree, that is Hevea brasiliensis. That means most of the rubber we are getting from the Hevea brasiliensis tree. So here, how we can get that natural rubber from this tree? By cut made of bark of the rubber tree, we can get a white color milky sap. That milky sap is known as latex. So first we can get the or obtain the latex from the rubber tree. By using this latex, we can synthesize the natural rubber by using some industrial method. So this natural rubber is consist of some organic impurities. They are fatty acids, proteins, and resins. Almost the natural rubber is consist of 95% of hydrocarbon, 4% of protein, and 1% of resin or impurities are present in the latex material. So how we can synthesize the natural rubber from the latex, I am going to show in the next slide. Now here you can see this is the total schematic representation of synthesis of natural rubber. First we can collect the latex from the rubber tree. This latex, first we have to do the dilution, almost 15 to 20% dilution. After dilution, we have to remove or filter the small impurities of leaves and bark of the rubber tree. These impurities we have to remove from the latex. After that, this latex is consist of some impurities, that organic impurities, fatty acids, proteins and resins. They are associated with this latex. So that mixture we can say the emulsion. So that impurities we are going to removing from the emulsion. After the removal of all these organic impurities, we are going to do the coagulation by adding of acetic acid or formic acid. So by adding of acid, either formic acid or acetic acid, we have to do the coagulation. Then that after the coagulation, we have to do the washing. So here while washing, if any excess of acidic components are there, we have to remove by washing. After the washing, the rubber material we are passing through the rollers, then we can get the rubber sheets. So these rubber sheets, now here you can see this white color creepy rubber sheets we are getting. So these rubbers we can do the dry either in presence of sunlight, or sometimes we can also dry in presence of smoked chamber for 3 to 4 days at 50 to 60 degrees centigrade. Then finally we are going to getting this type of natural rubber. So this is the simple preparation of synthesis of natural rubber from the latex of Hevea braziliensis tree. Coming to structure of natural rubber. So natural rubber is associated with isoprene units. What is the isoprene? 2-methyl-1,3-butadiene is known as isoprene. When we are seeing the structure of natural rubber with the help of X-ray diffraction, it possesses cis isomer. The cis isomer of isoprene units are known as natural rubber. If the isoprene is present in the transform, that rubber is known as gutta-percha rubber, but natural rubber is associated with cis structure. So this is the cis polyisoprene is known as natural rubber. So this is the simple structure of rubber material. Next one, moving to properties of natural rubber. So natural rubber is possesses low tensile strength, low melting point, and also it can easily get oxidation in presence of environmental gases. It should be soft and sticky nature. Okay, when we are doing the heating, it is undergoing soft. After cooling, it is going to be rigid material. And next one, it can be easily soluble in organic solvent, either ether, CCl4 or petrol. And the working temperature of natural rubber is up to only 60 degree centigrade. So here you can see the natural rubber is associated with very poor properties. With these properties, we cannot directly use the natural rubber in industrial application. So that's why in order to improve the properties of natural rubber by using one chemical process, that chemical process is known as vulcanization of rubber. Now I am going to discuss about the vulcanization of rubber. So here by using this proper process, we are going to improving the properties of natural rubber material. How we are going to do this process? So in 1839, Charles Goodyear scientist was introduced the vulcanization process. With this process, we are going to improve the properties of natural rubber by using or in presence of sulfur compound, right? Heating of rubber, natural rubber with sulfur component at 150 degrees centigrade, we can get a cross-linked vulcanized rubber. Initially here you can see the structure of natural rubber. It is a simple linear structure. While heating with the sulfur components, now the straight chain or linear chain of natural rubber is going to converting into a cross-linked structure of natural rubber. So this is the natural rubber structure. We are doing the heating with sulfur component at 150 degrees centigrade. These sulfur components are going to reacting at double bond center of the rubber material. Then that natural rubber is going to converting a cross-linked three-dimensional network structure. So here once it is going to converting the network structure, the properties of natural rubbers are going to tremendously increasing with the help of vulcanization process. After now we can see here after vulcanization how the natural rubber properties are increased. Initially we seen that it is low tensile strength, but after vulcanization the natural rubber becomes high tensile strength, and it can possesses high melting point, high elasticity nature, and initially it is soft and sticky, but after vulcanization it is hard and non-sticky material, and it is a good wear and tear resistance material. it is insoluble in organic solvents, as well as the working temperature of natural rubber is increased from 60 to almost 100 degree centigrade. That means, so with the help of vulcanization process, the properties of natural rubbers are greatly increased. So that's why now this natural rubber we can use it in industrial applications. Next one, moving to the uses of natural rubber. These are the various uses of natural rubber around the world. It can be used in making of tides, automotive components, clothes, flooring sheets, gaskets, rubber nozzles, and swimming tubes, erasers, and various other goods we can synthesize with the help of natural rubber material. Next one, moving to synthetic rubbers. So synthetic rubbers we can prepare in the laboratory with the help of chemical components. Now today here I am going to discuss about the two synthetic rubbers. They are Buna S rubber and butyl rubber. The first synthetic rubber is Buna S rubber. So Buna S rubber is also known as styrene butadiene rubber. So in the name only it is there. One of the monomer is styrene and another monomer is butadiene. With these two monomers we are going to synthesize the Buna S rubber. So Buna S rubber is a copolymer. Why it is copolymer? It is going to made up of with two different monomers. So that's why the Buna S rubber is a copolymer. Right. Here I am taking 75% of butadiene and 25% of styrene. Styrene is also known as vinyl benzene. So with these two monomers, by doing the addition polymerization, we are going to getting the Buna S rubber material. Actually, this Buna S rubber is prepared during the Second World War time to overcome the natural rubber material. So at that time we required more amount of rubber. So to overcome that problem, they synthesized this synthetic rubber during the Second World War time. And next one, properties of Buna S rubber. It is a strong and tough polymer, and it is also vulcanized, and it can be used as a good electrical insulator, and it is good resistance to chemicals, but it is attacked by sometimes the small amount of environmental gases like ozone in atmosphere. These are the uses of Buna S rubber. Especially the Buna S rubber, it can be mainly used in making of tires industries, footwear industries, mechanical goods, and also it can be used in the making of cables and wires. So these are the major applications or uses of Buna S rubber material. And next one, butyl rubber. The second synthetic rubber is butyl rubber. So it is also an example of copolymer. Again, it is also made up of with two different monomers. They are isobutylene and isoprene. So here I am taking the 98% of isobutylene and 2% of isoprene. Both are undergoing addition polymerization. It gives butyl rubber material. So this is the simple preparation method for the synthesis of butyl rubber with the help of two monomers. They are isobutylene and isoprene. Moving to properties of butyl rubber. So it is strong and again flexible polymer, colorless to yellow, and it is also vulcanized, similar way of natural rubber, and it is a good electrical insulator, and the working temperature of butyl rubber is up to 120 degree centigrade. And next one, applications of butyl rubber. So butyl rubber, it can be used mainly it is used in various industrial application, especially making of inner tubes of tires. So that is the one of the major application of butyl rubber, and it can be also used in automotive industries, industrial applications like manufacturing of conveyor belts, tank linings, and it can be also used in construction purpose, adhesive, consumer products, and also we can use it as a sealant materials, and it can be finally used in blood compatible substances. These are the various applications of butyl rubber materials. So with this I am going to concluding our today's session. In this session I covered natural rubber, its properties, vulcanization, and uses of natural rubber along with two synthetic rubbers. They are Buna S rubber and butyl rubber materials. Thank you.